Everyone, so for this async you have a short quiz to take care of. So I'm going to kind of walk through where to look for some extra help and walk through a couple problems to help you get started. So when you take a look at your quiz, you're going to see a couple questions asking you to find the equation of a line or the equation of an inequality. Then you'll see solving a system, and then you'll see some solving equations. We're not going to talk about this in class or in this video today, but you can look back at previous lessons for that. And then we'll also look at a problem really similar to the last question, which is a little bit tougher. All right, so if I wanted to find the equation for this line, I'm not going to give you this answer, but we'll take a look at a different example. So if I'm looking at a line and I want to figure out my equation for that line, what I want to do is start by finding the y-intercept and then the slope. So generally, the most common way we write the equation for a line is slope-intercept form, y equals mx plus b. The b represents our y-intercept, or in other words, where we touch the y-axis. So we can see that's happening right there at -4. So that's the first thing we can fill in. Now the last thing we have to add here, we always have our x and our y relationship. We've got to add our rate of change, our slope. So looking at the line, we need to find not only a single point, but we need to find another point as well. So this looks like a good one. We've got a point at 1, -1. So how do I get from this point to that point? Well, I'll have to go up 3. 1, 2, 3. See, we're counting by halves. Make it a little bit easier. I'll zoom out here. So to get to this point, I need to rise 3, run 1. So up 3 over 1. So that represents our slope. Going up 3 over 1, that's our rate of change. Rise over run, 3 over 1. Change in y over change in x. 3 over 1 is not a great way to write the answer though, because 3 divided by 1 is just 3. So we can simplify. All right, let's try another one with a inequality. So this time we don't just have a line, but we have some shading involved as well. We have this inequality going on. So it's going to be pretty much the same process. The only difference here is that instead of having an equal sign, we're going to have a less than or a greater than or a less than or equal to or a greater than or equal to. So we'll have to think about which one it's going to be, but we'll do that last. Okay, so we always have our x and y relationship. Then we start with our y-intercept. So we can see we're crossing the y-axis at 2. So we're going to have a plus 2 on the end, since we're crossing at +2. Next, we should find the slope. So here's a point, here's another point. So to get from there to there, we need to go down 1 and over 2. So down 1 to the right 2. So our rise was -1. Our run was 2, so -1/2. Again, remember it's change in y over change in x, rise over run. All right, lastly, we got to figure out what we need, because if it was just equals, we would just have a line. We wouldn't be dealing with all this shade and everything else. So how do we determine which sign we need? So the first thing we want to look at is that we have a dotted line, which means we need just less than or greater than. We don't need the line underneath. These rules can be a little bit tricky at first. But if you go back to the 1.2 slides, you'll see I go through all of this, and we specifically talk about how to do inequalities. So you can see that less than, y is less than, we shade below the line. And if it's just less than, not less than or equals to, we have a dotted line. Cool, so there's a good summary of these rules in your 1.2 slides you can go back to. It talks about slope and some other things as well. Cool, so we've got shading below the line, so y is less than, and then since we have a dotted line here, we don't want to add that. We want to leave that off. So again, y is less than -1/2 plus 2. Just to show you the difference if we had, a less than or equals to would just be that we have a solid line instead of a dotted line. Dotted line for less than, solid line for less than or equal to. All right, the next thing on your quiz, you'll have to solve a system of equations. So one of the ways we can do this is just by graphing. So if I just throw these two equations into Desmos, and I'm not going to use the same equations, I'm just going to make up some other junk so I don't give you the answer. So we put two equations into Desmos. We can find the solution to that system by finding the point that falls on both lines at the same time. Again, this is not the same one from the quiz, just an example of what you're looking for. You're looking for that intersection point. And finally, I'm not going to go over these, but again, you can go back to the 1.1 notes for some help with this. Let's take a look at this coin problem, because these are a little more difficult. This time we have to actually build our system of equations. So I'm not going to do this problem exactly, but we'll take a look at the problem that we did in class. So it says we have some coins in a jar, and we want to figure out how many quarters there are and how many dimes there are. The question on your quiz is a little bit different, so don't follow this exactly. All right, so X is going to represent the number of quarters we have. Y is going to represent the number of dimes. And we get a little bit of information here. There's 200 coins total. So if I put the quarters and the dimes together, we get 200. So that's our first equation. If I add number of quarters to number of dimes, it's going to add up to 200. The next thing I have to do, the harder part, is to come up with a value equation. These coins added together give me $40.25. So to get that equation, we're going to have to think about how much each coin is worth. So we know we got to add up to $40.25. Every quarter we have, every X, gives us 25 cents, right? A quarter is worth 25 cents. So however many quarters we have, we're going to multiply that by 25 cents to figure out how much it's worth. We can do the same thing with dimes. Dimes are worth 10 cents, so 0.10. And there's our value equation. Cool, so you'll do something similar. And when you do that, you can graph those two lines. So here I graph those two lines, and I find the combination that works. 135, 65. So I need 135 X's, so 135 quarters, and 65 dimes. Cool, so hopefully this helps you work your way through the quiz. You can always reach out to me if you have any questions. Thanks, y'all.